Hello everyone, welcome back. In this particular video, we will be discussing the problem merge overlapping intervals. So what we given in this problem is we are given a interval, or not just a single interval but a range of intervals. What is an interval? Interval is nothing but a range that is having a starting value and an ending value. If let's say a range is defined as 1, 3, it means the range is starting at 1, or the interval is starting at 1 and the interval is ending at 3. And the such kind of intervals will be given in an array. A lot of intervals will be given in a collection. Given a collection of intervals, what we have to do is we have to merge all of them, but merge overlapping intervals. So what is merging overlapping intervals? That we will figure out later on, but first let's read the problem statement completely. The result should only have not one, but should only have mutually exclusive intervals. Now, what is mutually exclusive intervals? The intervals such that no number should be common between two intervals. That is, they should be non-overlapping. They should not overlap. They should not have any point of time which is common in two intervals after we are merging them. So the merge intervals should be printed in increasing order of the starting value. Another note is the merge intervals should be printed in increasing order of the starting value. Now let's actually discuss some example to actually understand that what is merging. So given 4 intervals, that is the array size having 4. First interval is from 1 to 3. Second interval is from 2 to 6. Third interval is from 8 to 10. The fourth interval is from 15 to 18. After merging these 4 intervals, merging the overlapping part, the non-overlapping intervals finally will be from 1 to 6, 8 to 10, 15 to 18. Let's figure out how. So first interval, let's just make a range from 1 to 3. This is the interval starting from 1 going to 3. Next interval is from 2 to 6 as mentioned in the question. So let me just make an interval starting from 2 going till 6. What about next? Next interval is from 8 till 10. So if I draw a line from 8 till 10, this is what will get formed from 8 till 10. And finally, last interval is from 15 till 18. So it will be from here, let's say till here, which is 15 till 18. After merging them, as you can see, the first and the second interval, that is from 1 to 3 and 2 to 6, are having some common part. So what we have to do, we have to merge them, merge overlapping ones. And after merging them, the final interval will be starting from the earlier start point going till the later ending point. That is from 1 till 6 will be the merged interval after merging the yellow and the green intervals. What about red? Is a red interval overlapping with these two intervals? No, there is no overlapping portion. This is ending at 6, this is starting at 8. So no overlapping portion. So 8 to 10 will be in the output directly. What about 15 to 18? Again, no overlapping portion. They have a distance between them. So 15 to 18 will be taken in the output directly. But the point is how we can merge overlapping intervals, or how to figure out the overlapping intervals at the first place. See, if two intervals, for now, let's take only two intervals. If two intervals are overlapping, it means they will have some common portion. And how we can check whether they have some common portion? We can say if the first interval is starting from 1 and second interval is starting from 2, which interval is starting earlier? The first one, that is from 1. If this interval is starting earlier, but if it will end later than the second interval starting point, it means if this is ending at 3, but the other interval is starting at 2 itself, it can assume, or we can say that both the intervals are overlapping. Why? Because if it is starting earlier but ending later than the second interval starting point, of course they have some overlapping portion. They have some portion which are common between both of them. And not necessarily that the first interval will be the smaller interval, or you can say with the smaller starting point. It can be vice versa also. Like the order of the input is not given. We can have the intervals in input in any order. So let's suppose this is the first interval, this is the second interval. In that case also, what we will say, First of all, figure out the interval with a smaller starting point. This is the interval with smaller starting point, the second one in this case. Is it ending later after than the other intervals starting point? Yes, 3 is more than 2. So again, this is a overlapping portion. But this is a partial overlap. It is not necessary that the two intervals will have a partial overlap. Actually, there are 3 scenarios. There can be no overlap at all, like the way we have. First interval is, let's say this, second interval is, let's say this. This is from 1 to 5. This is, let's say, from 6 to 10. So no overlap among them. Second case is partial overlap, as you can see in the case, in the first case itself. That is, one of the intervals is, let's say, 1 till 5. Second interval is, let's say, 3 till 8. So these are having partial overlap between 3 to 5. But there is one more case which is complete overlap, and we have to take care of that scenarios as well. What does complete overlap means? It can have two different things. Let's say the first interval is this, second interval is completely inside the first one. It can be like this, like the first one is from 1 till 10, second is from 2 till 5. So this interval is completely inside the first one, so it is a complete overlap. Or it can be vice versa, the first interval can be completely inside the second interval. But should we say overlap only when the two intervals have some range overlapping, when the range is common between two intervals? What should we assume if, let's say, the first interval is from 1 till 5, second interval is directly starting from 5 itself and ending at, let's say, 10? How about these two intervals? Should we consider them overlapping? Should we consider point overlap to be actually overlap or not? So although it is not mentioned in the sample input, but if I will take the second sample input, the first interval is from 1 to 4, second interval is from 4 to 5. So these two intervals only intersect, only have common portion of a point time, which is 4. And in the output, as you can see, it is merged. It is only having 1 till 5, 1 to 4, 4 to 5, merged becoming 1 to 5. It means if these two intervals are there, even a point overlap will be considered a overlap. That is point overlap. In this case also, we have to merge it and make it become 1 to 10. So in this case, the output will be 1 to 10. In this case, also the output will be 1 to 10 because the second interval is completely inside first. In this case, the output will be 1 till 8. That is the smaller starting point till greater ending point. And in this case, of course, the output will have the same input. That is 2 intervals as it is. No overlap is there. So there can be 4 such scenarios. No overlap, partial, complete, or just a point overlap. But the point is, there are not just 2 intervals, there are multiple intervals. And if there are multiple intervals, we have to take care of all of them, not just intersect or not just figure out between 2. So one of the brute force can be just figure out all the intervals one by one and try to check whether it can be merged with any one of them or not. But this procedure will be repeated a lot of times till the point you are not able to merge any 2. Like you will start with 4 intervals, let's say, and they are given in any random order. Let's say this is the first one, this is the second one, this is the third one, this is the fourth one. They can be given in any random order. What you will do is you will try to take one interval and try to merge it with other ones. Then try to take the second one, try to merge it with other ones, and so on. And in order to do this, the time complexity might go into exponential nature. Why? Because you don't know that how many times you need to merge 2 intervals or not. So it can go to exponential, and the approach or the code in order to do this will also be very complex. Better will be to figure out some ordering between the intervals. That is, not just take any random interval and try to merge it with other ones, because in input random order is given. Let's just sort the intervals. But how should we sort the intervals so that we are getting intervals in some particular order, and we should take that order and check whether to merge or not. That ordering can be based on the starting point of the intervals. That is, we can just sort all of them on their starting points, or we can also sort all of them on the ending points. You can do it in any fashion. The code or the approach will slightly differ. What I am going to do is I am going to sort all the intervals based on the starting point. Although in the sample input, all of these intervals are already sorted on starting point, 1, 2, 8, 15. But it is not necessary. It can be anything. So let's just do what? Let's take one more test case where all the 4 scenarios as we discussed are there. So let's take the first interval. Let's take the second interval like this. Let's take the third interval like this. Let's take the fourth interval. Maybe we can say like this. And let's take the fifth interval like this. So these are some intervals, and let me just add one more interval so that in the output there are few number of intervals present. So this is one more interval. Let me give some ranges. This is, let's say, 1 till 5. Let's say this is 2 till 10. Let's say this is 10 till 20. This is, let's say, 15 till 18. Let's say this is 25 till 30. Let's say this is 32 till 35. So these are some ranges given, and we need to merge them. And as discussed, if we have intervals in the sorted form on the basis of starting point, we will be able to take one interval one by one and check whether to merge it or not. So we can easily just sort all of the intervals based on starting point using the comparators. If you know about comparators, you will easily be able to sort them. So I am just making all of these intervals in the order of their starting point. That is, this is the first one, this is the second one, third one, fourth one, fifth one, sixth one. Now, one by one, we will take them in the output, whether we will take them as it is or whether we will merge it with other one. So first interval, should we take it or should we merge it with any other interval? There is no interval in the output. So first interval we can take as it is. That is, from 1 to 5, we will take it as it is. Done. Second one, it is starting at 2. What is the last interval in the output? It was ending at 5. If the last interval was ending at 5, current interval is starting at 2, it means there is an overlap. And if there is overlap, they should get merged. So do not just push a new interval 2, 10. Instead of pushing a new interval, update the previous interval's ending point. Why? Because once these are merged, the merged interval will start from 1 go till 10. So second one is also inserted, we can say, because it is merged with the first one. Now take the third one. It is starting at 10. What was the previous interval ending at? Also 10. Point overlap. According question, point overlap should be considered overlap. That is, they should be merged even if there is a point overlap. So if we are merging it, the new interval will become 1 till 20. That is a maximum value of the ending point. Now next, fourth interval. It is starting at 15. What is the previous interval ending at 20? It means there is again overlap. This is the overlap, the entire overlap. In this case, this point overlap was there. So if there is overlap, we have to merge it. Previous interval ending at 20, current interval starting at 15. 20 is more than 15. It means there is some portion. But should we update the ending point as the current interval's ending point 18? Like this is what we were doing. Initially, it was 2. We updated it to 5. Or actually, you can say it was initially 5. We updated it to 10. Then after 10, we updated it to 20. But now, should we update it to a smaller value, 18? After merging this one with this one, will it have ending at 18 only? No, it will have ending at the maximum value, the 20 value. So this time we will not update the ending point. This time ending point will remain 20 because 20 itself is more than 18. 18 is smaller than 20. Although it is having 15 lesser than 20, but 18 also is lesser than 20. That is, this is a complete overlap case. In complete overlap case, just simply discard this interval. Now, next interval, fifth interval, this is done. We have merged it, just discarded it. This fifth interval is starting at 25. The last interval in the output was starting, or you can say ending at 20. So previous interval ended at 20, current interval starting at 25. There is a gap. If there is a gap, they are non-overlapping. So just simply push the current interval in the output. That is 25 till 30. Since we are pushing in the output, we don't know what will be the number of intervals in output. We can't be sure how many intervals will be there. Next one, sixth, 32 till 35. So it is starting from 32. Last interval in the output was ending at 30. Again, there is a gap of 2. So no overlap. No overlap means just push it in the output. So 32 till 35 will get pushed in the output. Finally, in the output, you can see there are only 3 intervals, and this is the merged form of intervals. And this is how we have to do it. So first thing, just sort all the intervals based on starting point. What will be the time complexity required? If there are n intervals, n ranges, it will take n log n in best optimized manner using merge sort, quick sort or something. And then running a for loop on every interval, checking whether to merge it or not will take linear time only. Why? Because running a loop will be linear, and checking whether should to merge or not, it is just a simple if else condition. So overall time will be n log n due to sorting itself. Although sorting line will be a single line, but time complexity will be dominated or will be recognized by the most amount of time whichever operation is taking, that is done by sorting itself. What about space? Since we are going to take extra space, since we are going to create an array list or a dynamic array, because we don't know how many intervals will be there will be order of n extra space required. Although if you want, you can do it in place also. For that, what you have to do is you have to just run the loop twice. First, to figure out the number of merged overlapping intervals, that is, there are 3 intervals in this case. So just first count the number of resultant intervals and then do it to store all of them. But that will be a little bit hectier in terms of the code. So what we are going to do is we are going to take extra space just to reduce the number of times we are running iterations. So now let's go to the instruction manual. First step, what we need is we have to sort all the intervals. So sort all intervals on the basis of starting point, on the basis of starting point. And how we are going to sort it? Using comparator. How we can sort it using comparator? We can say that in Java or in any language except C, C++, the comparators should return -1 when we are not swapping. It should return +1 when we want to swap. It should return 0 when both the values are same. So using comparator, how we can compare? We have to compare using the starting value. In a given array, there are 2 values, 0th index, first index. 0th index having the starting point, first index having the ending point. We need to sort on the starting points. It means the 0th index. So comparator will be comparing on both the intervals using the starting point. That is, it will return -1, or you can just simply say return the value of, since we need increasing order, return the current interval or the first interval starting point minus the second interval starting point. This is also known as this minus other. Return the first intervals starting point, first intervals starting point minus the second interval starting point. This is what we have to apply in the comparators logic. So for this problem, actually, you will require a prerequisite of comparators, because if you don't know comparators, this reason that why we are doing first minus second, or why we are doing -1 in the case of no swap, +1 in the case of swap, and 0 in the case of equal values, you will not be able to get it. Once we are able to sort all the intervals based on the starting point, that is first interval with the smaller starting point, next greater, and so on, we will maintain an output data structure. So create a array list, or you can say create a dynamic array. So if you are like coding in other languages other than Java, you will actually have something like vector or something like array list. So create an array list or a dynamic array resultant which will contain all the intervals of the integer array of the intervals containing intervals. So initially it will be empty, but one by one, we will keep on storing the interval in the output array. So for that, we will start from the first interval, that is run a loop, run a for loop over all the intervals one by one. We will take one interval at a time and check whether to merge it or not. So how to check whether to merge it or not? If the last interval, either it is not there, or we can say the last interval's ending point is more than the current interval starting point, then there is a portion of overlap. And if there is a portion of overlap, then we have to merge it. But in the case of last interval is not present, actually we have to not merge, because if last is not present, we can't merge it. So what we can first check is when to not merge. So we have to not merge when the last interval is not present at all, then we can't merge, or when the current interval's starting point is more than the last interval's ending point, or you can say last interval's ending point is lesser than current interval's starting point. If it is the case, we do not have to merge. In this case, we have to add the current interval in the output. So add the current interval in the output because we are not merging it. What we are saying is, for the first interval, since the previous interval does not exist, do not merge it, just directly add in the output. For this interval, since the previous interval's ending point is lesser than the current interval's starting point, do not merge it, add it in the output. Do not merge it, add it in the output. So these two scenarios we have to add in the output, that is do not merge, non-overlapping. Otherwise, if it is overlapping, then we have to update the last interval's ending point. Update last interval's ending point. Ending point as what? As the maximum of either the last interval's ending point itself or the current ending point. That is 5 versus 10, whichever is maximum, update it with that value. 10 versus 20, whichever is maximum, update with that value. 18 versus 20, whichever is maximum, update it with that value. That is updated with the greater ending point. So update the last interval's ending point as the maximum of the last interval's ending point, last or current ending point. So this is what we have to do. And finally, since we need to return the array in a static array form, so we have to just convert dynamic array into a static array by running a for loop. You can easily do it. Just transfer all the values, all the intervals from the array list into the array, or you can say vector into a simple static array, and then return the array, then return the static array. So this is what we have to do in order to solve this problem. Although the code will be very less, but the logic was more important. And as already discussed, time complexity will be n log n, space complexity will be linear. This will be the problem, merge overlapping intervals. We will write the code for the problem. We will be writing it in Java programming language. First of all, what we need is, we can't just apply the algorithm without all the intervals being sorted. This is a greedy algorithm, and for it, we actually need all the intervals to be sorted on the based on starting point. So for that, we can apply arrays.sort inbuilt sorting function, which will sort all the intervals. But we have to apply a comparator, and the comparator can be applied as a second parameter. This is how you can basically apply a comparator. In the second parameter, what we need to pass? We need to pass the two variables a and b, which will be the two intervals which we need to compare, because in comparator we have to apply the comparison logic. Then we can use angular the arrow operator, and then after the arrow operator we can use the curly brackets. This will represent a comparator using lambda expression. We are actually using a lambda expression to construct or to determine how we have to compare two arrays or two intervals. Two arrays will be of size 2 each, that is having two elements, 0th index having the starting point, first index having the ending point. That is, A is an array of two size, B is an array of two size, and we need to sort it in increasing order based on starting point. So we need to return what? We need to return A of 0 minus B of 0, because starting point is at the 0th index. This is how the sorting will work for the array of intervals. Let's just write it in one single line, because it is just a matter of a comparator, a one line comparator actually. So once we are able to basically write this comparator logic, what we need to do is, we need to, for confirmation, we can just for now print the array. So system.out.println arrays.toString intervals. Let's just print all the intervals. And for now, let's return the same intervals array itself, because otherwise returning will give you a missing return statement error. So hopefully the syntax is correct. Although there is no such syntax, maybe what we have to do is we have to remove the curly brackets, because there is only one line of return statement. We can just omit the curly brackets also. There is no need of curly brackets. Although if you will be requiring to return -1 plus 1, then in that case you have to basically have curly brackets, because there will be more than one line of code. So as you can see, like the objects are getting printed. Actually, we have to print all the intervals, not the objects, but we can assume that all the intervals are being sorted correctly now. Once all the intervals are sorted, what we need to do? We need to create a dynamic array. So array list is nothing but a dynamic array in Java of array of 1D array. 1D array will be an interval having two elements. Let's say this is resultant, and we need to basically have it initialized with empty array list in history. We will keep on getting one interval at a time. So we will run a loop over all the intervals. We can run a for each loop for that. So we will get one interval at a time, and we will ask whether to merge this interval or whether to basically add it. That is, consider it as non-overlapping or overlapping. When should it be considered non-overlapping? If the output does not contain anything. So we can get the last interval in a variable that will be last, named as last. You can get it in a variable, and you can just say in the resultant, get the last index, get the resultant dot size -1 index. But as discussed, that it can happen that last interval is not existing, that is the size 0. So if the resultant dot size is 0, in that case, just take it null for now. Otherwise, null pointer exception will be there. Now we need to check if last interval is not present, it means it is null. Or we can say if the last interval's ending point is smaller than current interval's starting point. Last interval ending point means first index, because ending point is at first index, starting point is at 0th index. Is smaller than current interval's starting point. It means it is non-overlapping. And if it is non-overlapping, we should add the current interval in the output. And how we can add it? We can just say in the resultant, just add the current interval. That's it. Add the current interval. Although the current interval is named as interval, let's name it CURR. That is current. But if it is overlapping, we have to merge it. Merging means just updating the end index, and we will make it updated as last of one, that is the ending index of the last interval, will be maximum of math.max of two parameters. Which two maximum? Either the same value, that is the ending index of the last interval, or the current interval's ending index, or the current interval's ending point. Once we are able to just insert all of these intervals in the resultant, we can't just return resultant. Why? Because return type required is a static array, but we have a dynamic array. So we have to convert the array list into the array by running a for loop simple. So we can create a dynamic array. Let's say we are naming it as answer. We can't name it same. Is equals to new int square bracket square bracket. First dimension will be nothing but number of rows in this array list, or you can say number of intervals, which is nothing but result dot size. And the second parameter will be nothing but each interval having how much size. Each interval will have two elements, starting point, ending point. So second dimension will be 2. And we can now just store all the values by running an index loop based starting from 0 going till answer dot length. And we can just make all the intervals stored in the static array. So answer of index will be the result dot get index. Get is the function for array list. Square bracket is the way for array. This is the difference in the syntax in Java. And now we can return the answer, not the array list, because answer is the static array. So if I will run this code, hopefully it should give me all the intervals in sorted order in merged form. Because in the question it was mentioned, we have to print them in increasing order of starting value. That is why we have done the sorting. And also, in order to apply the logic, sorting is required. Because if we have not sorted the starting points, we can't just say that we should compare the current interval with the last interval. Last interval will only be there if it is sorted, or you can say last interval will be adjacent only if it is sorted. So it is taking some time to run. I'm not sure why it is taking that much time. Let's wait for the output to come. Hopefully the code is correct. Let's till that point maybe go through all the code. So first of all, we are sorting all the intervals based on starting point. Then we are having an array list. Then we are running a loop over all the intervals. We are getting the last interval. If the last interval does not exist, take it null. Otherwise, take it at the last index. If last interval does not exist, or it is not overlapping, then what we have to do? We have to just simply add the current interval. That's it. Otherwise, update the last interval's ending point as the maximum of both the values. So this is also working fine. Like I think it should work fine. We have created an array of answers, and we are just storing all the values. Now there is some small error. Result dot add interval is not there. It is current. The current interval is named as CURR. So let's run it again and see. It might take that much time again. I'm not sure, but hopefully it should be correct now. Yes, as you can see, the sample input is working. Let's just submit it. And as discussed, all the point overlap, no overlap, complete overlap, all the corner cases are getting accepted. What is the time complexity of this entire program? We can say first we are sorting all the intervals. Let's say there are n intervals, so sorting will require n log n time because it is using the most optimized fashion of sorting. And just then running a loop over all the intervals, checking whether to merge or not, this is linear only. So overall time complexity will be n log n plus n, which is n log n in big O notation. And what about space? Since we are requiring an array list, which is not in the input, not in the output, so there is extra space of linear space complexity. Why? Because second dimension is just 2. There are 2 columns for each row, or you can say each interval will have 2 elements. So space complexity will be linear, time complexity will be n log n. That is the problem, merge overlapping intervals. A very good problem, a very important problem for interviews. There will be a lot of follow-ups which you can actually solve. There will be a similar kind of problems. This strategy is a very common strategy which you can apply in a lot of problems. Like instead of intervals, it can be named as meetings. Instead of intervals, it can be named as the train at a particular platform. What will be the arrival time? What will be the departure time, and so on. So there can be different stories formed. So you can go through all those problems. Until then, bye bye. Take care.